The question says that in a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power minus 3 meter square, and the distance between the plate is 3 millimeter. Calculate the capacitance of the capacitor. If the capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? Before attempting this question, we should have our concepts clear about capacitance. That capacitance is a measure of capacitor's ability to store charge per unit voltage. For a parallel plate capacitor, the formula for capacitance is epsilon naught A times D, where A is the area of plate of the capacitor and D is the distance of separation between them. Now the question said that calculate the capacitance of the capacitor, and the second question was, if this capacitor is connected to a 100 volt supply, what is the charge on each plate of the capacitor? So once we know the formula for capacitance, we can easily calculate it, because epsilon naught here for air is given by 8.85 into 10 to the power 12 minus 12 farad per meter, and A is given, that is area of the plates, and D is also given, that is the separation between the plates. Area is 6 into 10 to the power minus 3 meter square, and D is 3 millimeter, or it is 3 into 10 to the power minus 3 meter. Now substituting these values, we will get a value of 17.7 picofarad for the capacitance. And for the charge on capacitor, given the potential difference, we know its expression is C times V, or capacitance times voltage. Now capacitance is 17.7 and voltage given is 100 volt. So its result would be 1.77 nanocoulomb. Thank you.